Alright, so welcome to today's class. Okay, so in today's class we are going to focus on these three objectives. We are going to discuss what even and odd functions are. Okay, and then we are going to look at the inverse of a function and also the composite functions. Okay, so this is the roadmap for today. Okay, so we are going to start with the definition of even and odd function. Okay, so there are two ways, okay, in which you can determine, okay, whether a function is odd or is what, even. Okay, so the first one is the algebraic method. Okay, so let me be writing here. So we are looking at even, okay, and odd functions. Okay, so even and odd functions. So for even and odd functions, the questions that are going to be coming in your tests, in your exams, okay, would just be questions that will be asking you to find or to prove if a certain function is even or if a certain function is what, is odd. So we have two conditions. Okay, so if your function is even, then the following condition should be satisfied. Okay, so if a function is even, then it means that the f of x is going to be equals to the f of minus what, x. Okay, so if you have a function, let me write it on top here. If I have a function f of x, and then this f of x is the same as f of minus x, so meaning where there's x there, just replace a minus x and I'm still getting the same answer, okay, on the left and the right hand side, then we conclude that that function is even. And then if we talk about odd functions, then the following condition must be satisfied. Okay, so for odd functions, it means that f of minus x should be equals to minus of f of x. Okay, so this f of minus x and minus f of x, they are different things, guys. Okay, so usually students get confused. So here you have the minus x inside. Okay, so you are substituting the minus x in the given function, and then here you are just multiplying the given function by a minus. Okay, so these two are different. Okay, so these are the conditions that we are going to be using. So if you are using these two formulas here, this is the first one and this one is the second one. Okay, it means you are using the what, the algebraic method. Okay, you're using the algebraic method. And then the other method that you can use is the graphical method. Okay, but the graphical method is not usually asked. Okay, but I'll show you how you can also do that. Okay, so basically these are just the two conditions that we need to prove if a function is even or if a function is what, odd. Okay, so let's look at some examples here. Okay, so the question will be, state which of the following, okay, are even or odd. Which of the following are even or odd? Even or odd. Okay, so we are going to have a number of questions here. So let me say the first one, A. Okay, let's have f of x is equals to, let's say, 3x plus 2. And then B, let's say f of x is equals to x squared plus 4. And then I can add the third one there. Let's say the third one there is f of x is equals to, we can say x to the power 3 and then plus 2. So these here are the three questions that we had, okay, that we have, and then we are being asked to state, okay, which of the following are even, which of the following are what, are odd, okay, or are neither even nor odd. Okay, so we are going to start with the first one here. So on this first one, we are going to write our f of x. So f of x will be the same function that we can see there. Okay, and then what about f of minus x? So you always first try to see if if the function is even. So what about f of minus x? Okay, so if you put minus x there, it means wherever you have x in this expression, we are going to put a minus x. So this is going to be equals to, we're going to have 3, and then where there's x, we are putting a minus x, and then plus 2. So it means here the function will be what? Minus 3x plus 2. Okay, so we see that our f of x is not equal to f of minus x. Okay, so if f of x is not equal to f of minus x, then we say that the function is not what? Is not even. Okay, the function is not even. Alright, and then from there, once you prove that it's not even, you try to check if the function is what? Odd. So for odd, remember we must prove that f of minus x is equals to minus f of x. Okay, so we already have f of minus x, the one that we found here. So I'm going to write f of minus x here as minus 3x plus 2. Okay, and then what about this minus of f of x? So minus of f of x, it means we are multiplying the function of fx by a minus. So it will be minus and then f of x. So this simply means we have a minus and then we are multiplying 3x plus 2. So from here we see that we are going to get minus 3x plus minus 2. Okay, we're going to get minus 3x minus 2. So now you compare those two expressions that you have. Okay, this one here, you compare it to this one. So are these two expressions equal? We see that they are not equal. So we are going to say f of minus x is not equal to f is not equal to minus of f of x. Okay, so since this condition here is not satisfied, we are going to say the function is not even. Okay, so the function is not, the function is not odd. Hey, why am I writing even there? So the function is not odd. Okay, so from our calculations here, we found that it was not even, and it is again, it's not odd. Okay, so what will be our conclusion? We'll conclude that our function f of x here, okay, is neither even nor odd. All right, so any questions there? Okay, no question. So it means now we are going to go to the second one. Okay, so let's create some space here and then we solve the second one. So the second one, we are still going to follow the same procedure. We are first going to test if that function is even, and then we test if it is odd. Okay, so for even, we know that f of x should be equals to what? To minus of, to f of minus x there. So f of minus x. Okay, so f of x is just the same function, which is x squared plus 4. What about f of minus x? Okay, so f of minus x, it means where there's x here, I'm putting a minus x, and then I'm going to say squared and then plus 4. Okay, so we see that this guy here is going to be x squared plus 4. Okay, so if we compare our f of x and our f of minus x, we see that f of x is the same as f of minus x. Okay, so since this condition here is satisfied, we are going to say our function is what? Even. So it's as simple as that, guys. Okay, just follow the condition that must be satisfied, and then you'll be able to prove if a function is even or odd, or it's neither. Okay, so that was a simple one. Let's look at the last one there, the number 3, or the number C, or the letter C. Okay, so on the letter C, we are also going to use the same approach. So we are on C now. Okay, so our f of x is going to be equals to x to the power 3 and then plus 2x. Okay, let's find f of minus x. So f of minus x, where there's x, we put a minus. Okay, so this will be minus x to the power 3 plus 2 and then minus x. So in this first bracket here, what am I going to have? I'm going to have minus x to the power 3, and then there I'm going to have minus 2x. Okay, so this here is my answer for f of minus x. So we see that f of minus x and f of x, they are not equal. Okay, so f of x is not equal to f of minus x. Okay, so meaning not even. Okay, so the function is not even. All right, so let's try to prove if it's odd. So we have the f of minus x there that we have just from finding. So minus of x to the power 3 minus 2x. Okay, so let's find minus of f of x. So minus of f of x, it means we have x and then we are multiplying the function f of x. Okay, so when we multiply that x with whatever we have inside, it's going to be minus f to the power 3 minus 2x. So we see that, okay, we see that this guy here is the same as this. Okay, so f of minus x is actually the same as minus f of x. Okay, so we're going to conclude that this function is what? Odd. Okay, so that's that on the functions. Okay, so any questions there, guys? Any questions on the odd and the even functions? Any question there? Okay, so if there are no questions, then I'll move on to our second objective, which is finding the inverse of a function. Okay, so let's clean this part, or let's just go to the next page. Okay, so on this next page here now we are concentrating, okay, or we'll be discussing the inverse of a function. Okay, so we are discussing the inverse of a function. So the inverse, just from its word, okay, it means reverse. Okay, so if for example I have this relation here, okay, let's say this is my relation, I have x there, and then I have another set here which is y. Okay, so if I have a relation that goes from x and maps to y like that, okay, so this function that goes from x to y, okay, will be our function f of x. Okay, will be our function f of x. And then let's say I have another function now that does the reverse. Okay, it's coming from the y and then it's going to the x. It's going like that. Okay, so if it's coming from the y and then it's going to the x, that will be our inverse, and the inverse we represent it in this form. Okay, so just write f to the power minus 1, and then that will be your what? Your inverse. Okay, so this is how this is what the inverse means. Okay, it's just the reverse of the function that you have that you've been given. All right, so let's do some examples here. Okay, so what do you need to know in order to find the inverse? Okay, so you need to know how to make x the subject of a formula, and then once you make x the subject of the formula, you're going to express it as an inverse function. Okay, so let's say for example we have this simple function here. So f of x, let's say is equals to 2x minus 3. Okay, so and then we are asked to find the inverse. So what are we going to do? Okay, so you have to know that when it comes to function notation, f of x, okay, f of x is the same as y, guys. Okay, so wherever we see f of x, we can replace with y. So we are going to say this f of x here is the same as y, is equals to, and then we have 2x minus 3. Okay, so to find the inverse of this function, it means we're just finding the reverse. And how are we going to find that reverse? We are going to make x the subject of a formula. So we are going to say this is y, and then this minus 3 goes to the other side, so it becomes a plus 3, and this is goes to what? 2x. and then we want to make x the subject, so we are going to divide both sides by 2. Okay, so what we end up having is x is equals to y plus 3 divided by what? 2. So once you make your x the subject of the formula, and then you can bring in back the notation for the function. Okay, so that's this x here becomes f to the power minus 1 x, and then is equals to, and then this y here changes to x. So you're going to write x plus 3 divided by what? 2. So that function there, okay, this function I'm putting in red here, is the inverse of this function. Okay, so that's how we find the inverse. Okay, that's how we find the inverse. All right, so let's look at another example maybe. Okay, let's look at another example. So let's say we have the following function. Okay, let's say f of x is equals to let's say 4x minus 2 divided by x plus 1. Okay, so let's say this is the function that we have. So how are we going to find the inverse? Okay, we are going to say, first of all, the f of x is the same as y, so we're going to replace that f of x with y, and then we're going to say this is equals to 4x minus 2 divided by x plus 1. So our goal is to make x the subject of the formula. Okay, so we can put this y over 1, and then we cross multiply. So what are we going to have? We're going to have y multiplied by x plus 1. We're going to get x y, okay, plus, and then we're going to have y is equals to 4x minus 2. So take all the like terms to the left side. Okay, so whatever term has x, we are going to put it here. So xy, and then minus 4x is equals to, okay, and then we can take this y to the other side, so it's going to be minus y, and then we still have this minus 2 there. Okay, so from this xy and 4x, we can factorize the what? The x. So we're going to say x, and then in the brackets we're going to remain with y minus 4, and then this is going to be equals to minus y minus 2. Okay, we can divide both sides by y minus 4, even this side by y minus 4. So here we're going to have x is equals to minus y minus 2 divided by y plus 4. Okay, so once you make your x the subject, okay, you can now put it back in the set inverse and in the function inverse notation. So we're going to say this x here, okay, will become f inverse of x is equals to, and then wherever we can see a y, we're going to change that into an x. So it will be minus x minus 2 divided by, okay, someone has raised their hand, you can ask, plus 4.
So you've put y plus 4 down there when it was coming as y minus 4.
Oh, okay, I can see. Oh, yeah. So this one here, it has to be a negative. Okay, that one has to be a negative there. So let's put a negative there. So minus, and then even here you put a minus. Okay, so this one here is our inverse. Okay, so any questions on how we've been able to do that? Alright, so let's do one more question, and then I'm going to show you something that is interesting about a function and its inverse. Okay, alright, so let's do one more question. Alright, so let's find the inverse of the following function. So f of x is equals to 2x minus 1 divided by x plus 2. Okay, so as usual, this is going to be y is equals to 2x minus 1 divided by x plus 2. This over 1, cross multiply, we're going to have xy plus 2y is equals to 2x minus y minus 1, and then you take all the terms with x on your left, so it will be xy minus 2x is equals to minus 1 minus 2y. Okay, factorize the x from here. We're going to have x y minus 2 is equals to minus 1 minus what? 2y. Okay, so and then divide both sides by y minus 2x, so it means our x is going to be equals to minus 1 minus 2y is equal divided by, we have y minus what? 2. So we're going to say the inverse here is just minus x is equals to minus 1 minus 2x, and then we are dividing this by x minus 2. Okay, so this here is the inverse of the function. Okay, so now let me show you something that is interesting about the function, okay, and its inverse. So if two functions, okay, so if two functions, let me go forward. Okay, so if two functions, let's say f of x and g of x, okay, if two functions f of x and g of x are inverses of each other, okay, then their composite function, okay, will always be equals to x. Okay, so if this f of x, okay, and this g of x are inverses of each other, then when you find the composite function f of gx, okay, or you find the composite function g of fx, okay, this here should and will always give you what? X. Okay, as long as these two functions here are inverses of each other, then when you find the composite there, okay, of f of x with the g of x, it's always going to give you x. Okay, it's always going to give you x. So remember the first function that I wrote there. I said we had f of x is equals to we had 2x minus 3, okay, and then we found the inverse of this guy to be f of x is equals to 3x, I mean 3 plus x, and then divided by 2. Okay, so these two functions are inverses of each other. So it means that when you find the composition of these two functions, okay, it's always going to give you what? X. So let's try. So let's say we find f, okay, of f inverse like this. Okay, so this simply means that wherever there's x, we are now putting the whole inverse function. Okay, so what I'm going to do is, first of all, I'm going to write the function of f of x here. So f of x is 2x minus 3, and then now where there's this x here, I'm going to substitute the function of the inverse of f, which is a 3x plus 2. Okay, so let's create some space on top here. Let's create some space on top here. Okay, so let's try to find. So we're going to say f of f inverse of x is just going to be equals to 2, and then where there's x there, I'm going to substitute the function of f inverse. Okay, so f inverse is just 3x plus x divided by 2, and then I have a minus 3 there. So from this, what am I going to get? Okay, we see that this 2 and this 2 is going to cancel out, so I'm just going to remain with x plus, I'm going to remain with 3 plus x, and then I have another minus 3 there. Okay, so we see that this 3 and this 3 are going to cancel. We are just going to remain with what? X. So this is always the case. Okay, when you find the composite of a function with its inverse, the answer should always be what? X. Okay, so those are some of the exam questions that come. Okay, they can say show that the function, okay, they give you a function and the function and they give you another function, and then they ask you show that these two functions are inverses of each other. Okay, so for you to show that those two functions are inverses of each of each other. Just find the composition of those functions. Okay, if the answer is going to give you x, then you know that those two functions are what? Inverses of each other. Okay, if the answer is not going to give you x, then we know that those two functions are not inverses of each other. Okay, so that's how we are going to be using that concept of the inverse and the function. Okay, so any questions, guys? Any function, I mean any question? Okay, so lastly, I can talk about the composite functions. Okay, so the composite functions, I know they are not hard because you've been doing them. Okay, so the composite function, it simply means you are getting one function and then you are putting it into the other function. Okay, or you are substituting it into the other function. That's what it means for functions to be composite of each other. Okay, so let's take a look at some of the examples here. So I'm teaching you all this because they are the basics that you are going to need for whatever you're going to do under functions. Okay, this concept that I'm teaching you will be very important. Okay, so let's say composite functions here. Okay, so composite functions, we are getting one function and then we are substituting it into another function. Okay, all right, so let's say for example our g of x is equals to 3x plus 5, and then our f of x is equals to maybe 2x plus 3 and then divided by 4. Okay, so these two functions we can be asked to find the inverse. Okay, so what do we do to in order to find the inverse? Okay, so let's find maybe in this case let's find um, okay, let's find g of f of x. Okay, so how can we find this g of f of x? So the notation for the composite function can also be written as g of f. Okay, so this g of f and this g of f of x is the same. Okay, so this is equals to that there. Okay, so let's find the composite function there. So we're going to say this here we're going to be equals to, we have f of x there is equals to, so first of all we have to write the function of this g. So the function of g is 3, and then where there's x here I will now substitute the function of what? F. So the function of f is 2x plus 3 divided by 4, and then I have a plus 5 outside. So this is going to give me 6x plus 9 divided by 4 plus 5. So that's what I have there. Okay, so you can add those two expressions there. Okay, so you can say this 5 over 1, and then the common denominator there you can set it to be 5, to be 4 I mean. So we're going to say this is equals to, and then we set it 4. So 4 into this, it will be 6x plus 9. Okay, and then we are going to say plus. So here we have 1 into 4, and then 4 multiplied by 5. We are going to get 20. So that there is going to give us 6x plus 29 divided by what? 4. Okay, so this one here is the composite function for g of x. Okay, that's the composite function for g of x. All right, so some special notation under the composite function is when they give you they ask you to find f of f. Okay, so how can we find f of f? So let's say for example our function is f of x is equals to maybe 2x plus 5. Okay, and then they ask you to find f of f. So this f of f can also be shown as f of x. Okay, and it can also be shown as f squared. Okay, so when you see f squared here, they don't mean you get this equation here and then you square it. No. Okay, so under composite function, it means you're just finding f of x. So f of x, okay, you f of x, you are just substituting, okay, the f into the f, so it will be 2, and then where there's x we put the function 2x plus 5 and then plus 5. Okay, so this is going to give me 4x plus 10 and then plus 5, and then my final answer is going to be 4x plus um, this is 10 plus 5, so this will be 15. Okay, so that one here will be our f squared, or f of f. Okay, so those are some of the special notation to take note of. Okay, so when they ask you to find maybe f of 3, okay, so f to the power 3, it means you find f of x, okay, and then you find this f of x like that. So you've seen the way I've arranged them, right? So you find f of x, and then this f of x you substitute it into f. Okay, so any questions there, guys? Any questions? All right, so if there are no questions, then this is what we had for today's lesson. Okay, so when we meet in math again, we are going to start quadratic equations. Okay, so quadratic equations, then after quadratic equations we go to the cubic equations, where we are going to learn this long division method, the synthetic method, the factorizing method if you have an x to the power 3. Okay, so we are going to learn all these. Right, so if there are no questions, have a blessed night.